We'll get started. Good morning. I'm Deborah Bogar, facilitator for this 1-hour NACD Urban and Community Conservation webinar on Model My Watershed. This webinar is being recorded and will be posted on NACD's website along with a presentation PDF for your future access. You should be connected online to see the presentation, and you can access audio via your computer or by phone. Those directions were sent to you with your confirmation email. And as this opening slide indicates, all lines are muted except for the speakers. I'll open the chat area after the presentation so you can type in your questions, and we'll take as many as we can. You might want to jot those down during the presentation so you have them handy when we get to that area. In this webinar system, the transitions will take a few seconds as the presentations load, so don't worry that it's your computer. Let's get started with some comments from our host, Ron Rohal, Chair of NACD's Urban and Community Resource Policy Group, which is a subcommittee of our Natural Resources Policy Committee. Ron?
And good morning, and I welcome all of you to the monthly Urban and Community Conservation webinars offered by the National Association of Conservation Districts through the support of our sole sponsor, the Scotts Miracle-Gro Company. These sessions are designed by NACD's Urban and Community Resource Policy Group, a subcommittee of district officials and partners charged with guiding the association's services and support for districts in developed and developing areas. Our goal through these webinars is to help districts share what they are doing nationwide and enable them to learn from each other and various agencies and organizations. And we appreciate the support of the Scotts Miracle-Gro Company for making them possible. I invite all of you to let us know what you think of each webinar and what other topics you would like us to cover by contacting NACD staffer Deb Bogar. And please, tell our NACD officers what type of assistance you would like from your National Association for your urban and community conservation work. And now, I'll hand it over to Deb for the introduction of our speaker.
All right, thank you, Ron.
Welcome.
We have one presenter today. Dr. David Arscott is Executive Director and Research Scientist at the Stroud Water Research Center. He is a stream and river ecologist and has published research on riverine biodiversity, biogeochemistry, floodplain ecology, ecohydrology, and land-water interactions. He has field experiences that range across the U.S. and globally from the European Alps to the Southern Alps of New Zealand, from the Arctic to the Antarctica, and in Central America. He received his PhD from the Swiss Federal Institute for Environmental Science and Technology, his MS from the University of New Hampshire, and his Bachelor of Science from Central Michigan University. David co-leads Wiki Watershed and Environmental DIY.org initiative with other Stroud Center team members. And with that, I'm going to open the pod for you, David, so that you can go ahead and share your screen.
Okay, thank you, Deb, for that introduction. Thank you for inviting me to share some of our work via this forum. Good morning or good afternoon to all of you on the phone on the webinar. Welcome the opportunity to share this free online resource called wikiwatershed.org over the next 45 minutes. This is an online web-based software tool that you could either watch me work through some work flow paths or open a web browser and follow along with your own project. I'll give a brief introduction and then we'll go right into the online training and examples to show you what Wiki Watershed and Model My Watershed can do. So for those of you that are unfamiliar with our Wiki Watershed initiative, this is an online toolkit intended to meet many different audiences' interest and use. The website is wikiwatershed.org. And before I get into the details of the online tool, I would like to acknowledge the team members I'm one member of a fairly large team that's working to bring this tool to everyone here in the United States, if not eventually globally. There's many science leaders here at Stroud Water Research Center involved, as well as other institutions around the country that have contributed knowledge about watershed modeling, hydrology, and mapping and map software. The tool itself, the software, has been developed with the help from a Xavia, which is a design company in Philadelphia. So thank you to all of these folks and the institutions for being part of this team. We've, over the last 10 or 12 years, had significant funding from the National Science Foundation, William Penn Foundation, as well as Stroud Water Research Center to make all of this happen and bring this to the state that you'll see it in just a moment. When you open your web browser and type in wikiwatershed.org, you'll go to our landing page that looks something like this, and I'm going to jump there now and introduce you to all of these tools, but really we will spend the most time on Model My Watershed and drill down on this software web application. So at this point I'm going to abandon my slides and open a web browser. So hopefully now you are all seeing my web browser and can see wikiwatershed.org landing page. On the landing page there are currently 6 tools that we're highlighting with pathways to access these tools. Model My Watershed is a tool to analyze map data and run hydrologic and water quality models on different areas of interest in your landscape. And we'll come back to that in a moment. The model microsite runoff is really an educational tool to explore how Model My Watershed works by just looking at one parcel of land and running scenarios of how water moves through that land parcel. The Enviro DIY toolkit or effort is another website that we have developed and support, which is a social engagement website for people that are interested in do-it-yourself, open source hardware, software solutions for environmental monitoring. I gave a webinar yesterday for Penn State Extension. You can find a video webinar of our Enviro DIY initiative on this website here under Help Videos. A couple other tools that are available are LeafPack Network to explore critters in your streams using LeafPack deployments, a water quality mobile app that one can download and enter data, water quality data, and explore tools for learning what different physical, chemical, and biological parameters are. For example, pop-ups that tell you what pH is or what a mayfly is or different critters in the aquatic environment. And then there's the Model My Watershed tool as well, and you click on that and you will open a data access visualization tool that will allow you to search for water quality and other information throughout the United States. So back to the Model My Watershed app. Let's just launch this application, and when we do, we go to app.wikiwatershed.org, and the map should zoom to your geography. I'm sitting here in Pennsylvania, just west of Philadelphia, near the Delaware, Maryland, Pennsylvania border. And Stroud Water Research Center is located in Avondale, Pennsylvania. I know we have a national audience, and I'm going to zoom actually to where our host, Deb, is sitting in Fort Collins, and we can do that by either scanning the map and zooming in to an area of interest or using the white search bar at the top, and I could type in Fort Collins. Colorado. Click on that, and it should zoom right into Fort Collins. Zooming in and out with either the plus minus down here, or perhaps you have a scroll bar feature on your mouse, and dragging the map around is other ways to navigate these maps. The square box down at the bottom of the map screen here is a layer control. You can minimize or expand that layer control. And then there are a number of tabs on this layer control that give you access to different types of map data. This one on the far right is called base maps, and what we're looking at right now is a street view map that comes from OpenStreetMap that we're pulling into this software framework. We also have a satellite feed. These come from Esri, map archives, satellite with roads that happen to be a Google imagery product, and a terrain map. A little bit like Street Map, but we also do get some contour lines in here in certain areas. All right, so that's the basics of the map layers. There are some other layers of interest here. If we click on this Streams tab, we can turn on and off the streams layer, which are at a medium resolution level for the whole United States. And you'll see as we zoom out, the detail on the streamlines becomes a little bit less as we zoom out for the whole nation, and there's more detail of the headwater streams as we zoom back in. And zoom back to Fort Collins here. And I'm going to zoom in a little bit further here, and I'm going to do a few more things before we get started. Introduce you to the rest of this window. Up in the upper corner is a login window. And actually, upon your first time entering Wiki Watershed, you may be asked to register. You don't have to register on site, but if you do register, it is free, and you can save projects and share projects. I, of course, already have a login, so I'll log in. But if you don't want to create a login, you can continue as guest, and you'd have access to everything except saving and sharing your projects. So now I'm logged in. The first time you log in, you may also be asked for some demographics, your name, your organization, and the user type that you might be using as a university person, a government official, etc. All right, so where we're headed here on the workflow is to delineate some area of landscape on this map and then start to explore the architecture or the land use and soils and other features of that landscape, and then model how water moves through that landscape and how water quality may be affected as it moves through that landscape. So let's hit this click the Get Started button, and we'll go to Select Area, then Analyze, and then Model is the workflow. So when we get started, we have a number of different ways to select an area on the landscape. I'm going to start with a very simple one that's under the Draw area and use the free draw to draw a boundary. Your boundary can be any sort of polygon, triangle, rectangle, hexagon, or whatever, but if there's an area that you're interested in, you can simply click on the map and complete the shape. And once you complete the shape with a double click at the end, the map clips out that landscape and runs some algorithms to assess the land cover, the soil types, and some other data, and then it summarizes those data for us in this left panel. So the first tab here is land, and this is land cover distribution. This comes from the National Land Cover Database, which was published in 2011. And we have different categories here of land uses within this parcel that sum up to 100% of the area of interest. And down below we have a table that gives us the actual area in our polygon by the type of land use. We could select this table and we can copy and paste these data into a spreadsheet if we'd like to collect those and work with those numbers. Or we can download those data into a comma-separated value file that you can then save on your desktop and rename and open in a spreadsheet program. If you're wondering what this land use data layer looks like, you can toggle the land use map on and off with a little turn on, turn off toggle here. So we can see now the color coding matching the bar chart on the left, where we have red, pinks, and sort of light pink hues that represent developed space, ranging from developed open space to developed high-intensity space represented on the map. The yellow here represents the hay pasture category. Blues represent some form of wetlands or water. There's another place to access the color code for each of these down on the Layers tab with the little info button next to the land cover database layer on this grid panel here. And we can turn this on and off here as well. And we can also change the transparency of this layer so that we could see the underlying map through the transparency of the land cover. This is quite helpful if you're wondering whether or not the land cover database correctly classified your landscape. If you go back to base maps, you can turn on the satellite or satellite with roads and get a little bit better understanding of what the picture looks like from satellite view, where the trees and the pasture or hay fields are versus the urban infrastructure. And then we can slowly decrease the transparency of the land cover grid and get a little bit more comfortable about the land classification that we're looking at. The next tab under selected area is a soils tab. These are the hydrologic soil groups from the USDA's GSERGO 2016 map source. And again, we can turn this map, color-coded map, on and off and change the transparency down here of this map. These are national maps, but the data summarized on the left here are data specific to your area of interest. And again, we have a bar chart showing high infiltration soils ranging down to very slow infiltration soils, the percent coverage in your area of interest, and then a table with the exact area coverages that you could copy-paste into a spreadsheet, or you could download as a separate comma-delimited file. All right, so these two layers are the principal layers by which we need to gather that information to understand how water moves through this landscape or predict how water might move through the landscape. So they're really critical pieces of information for running hydrologic and water quality models. A couple other data layers that are incorporated and important in this regard are the number of farm animals in your parcel. So these data come from the USDA's county-level farm census, and they would be an estimate of the animals in that county on agricultural lands. And what we're doing is we're then distributing them to the agricultural land within your area of interest. If you want to find out more information about any of these data layers, there's usually a little information tool right next to the data source that pops up a link that goes to a technical document on another web page. And that technical document, is here on the Wiki Watershed homepage. And you can find this under Help, Documentation, Technical Document. And this document will lay out every single layer that you're looking at. So if you're wondering where these coverage grids come from, we have references for the land cover database where you could go and source those original data yourself, the GSIRGO data set, climate, as well as other data are all referenced in here. The third data layer are point source discharges. So this is also pulling in a national map of EPA's permitted point sources from the National Pollution Discharge Elimination System. And of course, in this small parcel area, what this is telling us is we don't have any permitted point sources from this database within our area of interest. All right, so that's the basic view when you select an area, and we've now gathered and reviewed most of the information we need to understand how water moves through the landscape. The next step is then to model water moving through our landscape, and then think about how we can modify or the landscape might change and how that might influence hydrology and water quality in our region. There are two models to choose from when we click on Select Model. One we call Site Storm Model. The other is Watershed Multi-Year Model. Just from the title, you might get the feeling that there's some difference in spatial scale that's most appropriate for each of these models. And indeed, that is the case. The Site Storm Model works better with smaller landscapes. The Watershed Multi-Year with a little bit larger landscapes. This parcel, this area of interest I've selected is closer to the scale that the Site Storm Model would be more applicable. The Site Storm Model also differs from the Watershed Multi-Year Model in that the Site Storm Model simulates a hypothetical 24-hour storm event, whereas the Watershed Multi-Year Model simulates the historic 30-year record of daily precipitation from climate stations nearby your area of interest. So I'm going to select the Site Storm Model to start here for our first example. And when we select that model, the algorithms running beneath this model are based on SLAM, which is an urban stormwater hydrology model you may have heard of, and a TR55 model, which dates back to the Soil Conservation Service 1972, I believe. Maybe I got the date wrong there. But this is a model that's used in rural and agricultural landscapes for predicting how rainwater moves through the landscape. So depending on the percentage urban or the percent rural, these models are running and raining down water on this area of interest. The default over here on this precipitation slider is 2.5 centimeters of rain over the last 24 hours. I can change that default down to 0, rerun the model. There's no result because there's no rain. And I can slide that all the way up to 25 centimeters, which is quite an extreme rain event. I think for our purposes, we'll keep it around 5, which is about a 2-inch rainstorm. That's still a fairly rare event, perhaps, for this geography. You can see the model was updating every time I changed the precipitation. And this model partitions rain into evaporation. So out of 5 centimeters of rainfall, the model predicts 0.4 centimeters are evapotranspired, 1.4 centimeters run off this landscape, and the assumption is they would run into our wetlands, creeks, or lakes, and 3.2 centimeters infiltrate to groundwater. And of course, down here you have the raw data from that model in this table. Again, if you want to find out more about how these models work, we have all of this laid out in our technical documentation. There's a section here called Model Water Quantity and Quality, and the site storm model is what we would access. And then we have links to more technical documents if you would like to understand more about how these models operate. No, let me go back here. This is a good time to back up quickly and explore the Model Microsite Runoff educational tool, which helps us better understand how these algorithms for routing water through the landscape are working. So this little cartoon is for a pixel or a parcel of land that has a certain land cover. Here it's developed low-intensity land, 24-hour rain event, that's a 5-centimeter precipitation event, and that landscape is on high infiltration soils. One can click through to change the soil type and see how the model parameters would respond as far as evapotranspiration, runoff, and infiltration for that 5-centimeter storm. Or we could change the landscape type from developed to forest to cropland to see the relationships between how water moves through and land cover. And then, of course, we can change the amount of rain that we have coming through that pixel. So for those of you that are running education programs or interacting with the public and thinking about explaining this model to the general public, this might be a useful resource. All right, back into the model. We've reviewed the runoff tab here. There is another tab that is called water quality that is a prediction of total suspended solids, total nitrogen, and total phosphorus that would run off this landscape based on that rain event. This is simulated by using algorithms that are referred to as the EPA's Step L spreadsheet model. And again, we have documentation if you want to learn more about that model in our technical document manual. So here we have a certain amount of suspended load, nitrogen load, and phosphorus load. So all this is the foundational information of the model given the landscape here. We can then also simulate how changes to this landscape may influence both runoff and water quality. In order to do that, we click over here on the upper right-hand corner, this plus add changes to this area link. And when we do that, we open a new scenario, and we have these green tabs appear, land cover and conservation practice. When we click on either of those tabs, we have several options that appear to change the landscape in our area of interest. So for example, if we are wondering, hey, if we lose this park near the river to some sort of development, what might happen to the runoff? So let's put in a low developed area and change this park into a developed area by clicking on the map and drawing a polygon that represents the area of our developed landscape. When we close that polygon, the model updates and gives us a new prediction for runoff, infiltration, evapotranspiration, and a new water quality prediction for this new landscape. So with this scenario, to keep track of what we're doing, we can come in here with this drop-down and rename this. And we could rename it Developed low as a scenario. Then what I'm going to do is pick a new scenario. And on this one, I'm going to come in here and say, looks like this is the City of Fort Collins Utilities. They have a project to install porous paving in their parking lot to better manage stormwater. And they're just going to work on this part of the parking lot. So this is an urban best management practice that I've just implemented on the landscape. The software keeps track of the modifications over here. So we can see I've installed porous paving to this size area, 16,000 square meters. I could delete it if I decided I made that in error and didn't draw it correctly. And we can draw a bigger area or a different area on the map. And then we can label this scenario name. Yes, paving. Okay, so now I have these three scenarios: current conditions, developed low, and pervious paving. And I can look at the modeled results for each one of those by switching to that scenario through the drop-down menu. Or I can hit the compare feature and open a window that compares these projects or these scenarios side by side for a given amount of precipitation. We have a runoff tab and a water quality tab we can toggle between. And we actually have four scenarios up here. We have current conditions, the developed modifications that I made, and the porous paving. In addition to that, we've also included an example of what the landscape would look like if it was predominantly forested. So now you can compare and contrast these bar charts all side by side. Look at the combined hydrology, how evapotranspiration changes, how runoff changes, and infiltration changes. And then we can click over to water quality and see if we've made any impact on the estimates for water quality with these projects. And indeed we have. Of course, these estimates are all linked to the amount of rain that comes through our landscape. So anytime you update the precipitation, 24-hour precipitation event, the model output values will update for that new amount of water. We can toggle between the graphs or the bar charts as well as the data tables. And again, you can copy and paste these data into a spreadsheet program, or you can click the download and download those data as a comma-separated value file. And to exit, we can exit that. If you are logged in and you have an account, you can save this project. And when you save it, it's probably best to name it so you know what it is. Fort Collins. Click Save. Now that name appears. There's a few other tabs here. The Details tab helps you keep track of the area you selected, just how large it is, and which of the two models that you've run. At any time, you can click Analyze to go back and look at the land cover data and toggle back to your model results. And then finally, if you'd like to share this with a colleague or anyone out there, you first need to make the project public. There's a little window here that says, this project's currently private. Are you sure you want to make it public? Anyone with the URL will be able to access it. So you hit Confirm. And now when you hit Share, the URL pops up. You can copy this link and then paste it into an email or text it to somebody, and when they click on the link, this project will show up in the app for them to view, even if they do not have an account. Under your My Projects tab here, you can access all of your saved projects and manage them from this dashboard as well. You can make them public or private, you can share them, delete them, or relaunch the project. So here's another Fort Collins neighborhood project I did a couple days ago with Deb in preparation. So this one is saved. It's a little bit different geography, a little bit different scenarios. Made the entire polygon a grassland instead of the scenarios that we just did. All right, so I have about 10 or 15 minutes left. I'd like to share with you the other model and a few other features that we have available. Both of these models are available for you to use nationally. And so I'll just zoom out quickly and show you some of these national data layers that we have available. So land cover, turning this on and off, and decreasing the transparency, shows you that national land cover map that's color-coded for each of those categories. We can turn on and off the hydrologic soil group information. There's also a layer here that shows us the mean monthly precipitation nationwide, and a key here to show you the color code and what that means for millimeters of precipitation per month. And then a slider bar pops up and allows you to slide through every month of the year. I believe these are 30-year average lookbacks. I might be off on that, so let's go and have a look at coverage grids and see what we have. So these data, the mean monthly precipitation and temperature, are actually sourced from the PRISM climate group. And these are average precipitation and temperature data coming from the time period 1981 to 2010. We get asked that question quite a bit, so it's there in the documentation for you. So there's mean monthly precipitation and mean monthly temperature data sets here for you to explore. Let me turn that off and go into the next example. I think I was going to go to Madison, Wisconsin, and there is, if you've ever been to Madison, you know there's two wonderful lakes that the city is situated on, and the watershed draining into those lakes is largely agricultural with some urban around the lakes, and it's the Yahara River. And so we can select by boundary here. When we choose this mode of selection, we can select the USGS's subbasin units, watershed units, or subwatershed units, county lines, congressional districts, or school districts. I'm going to choose the Huck 10 scale, and you'll see that, just a moment, get the terrain map on here. You can see some faint red outlines appear, and those faint red outlines are the watershed boundaries defined by the USGS's hydrologic unit codes at the scale of the Huck 10. And when we mouse over the map, we get names of these subwatersheds. So I'm going to select, I'm going to click on Headwaters Yahara River. And when we click on it, it selects the area and cuts out the land use, soils, animals, point sources for us. And again, we can go in and explore the land use, we can see that this is a highly agriculturally influenced watershed, lots of cultivated crops and some hay pasture, and a little bit of urban along the streams coming into the lake. And the soils data are here as well for us to explore. Animals, of course, this is a big agricultural area, so our animal census data is going to have quite a few animals that are predicted to be in this landscape. And point sources, looks like we don't have a permitted discharge in this area either. So this time I'm going to select a model to run. I'm going to run the Watershed Multi-Year Model. And when we click on that, the algorithm runs. This model was developed at Penn State University by Barry Evans, and it is running what's called the GWLFE algorithms. This is a generalized watershed loading function model that was actually first proposed by people, I believe, at Cornell, that Barry Evans modified and has called MapShed. And this model is a model the state of Pennsylvania uses for some regulatory purposes like total maximum daily load accounting. So we've implemented this model here that looks at 30 years of daily precipitation data and pushes those average daily precipitation values through this landscape. And we can see the precipitation regime by month here that the model is using as input to push water through the landscape. And there's a drop down to toggle to evapotranspiration estimates, surface runoff, subsurface flow, point source, and stream flow estimates. This is water depth in centimeters as a fraction of the amount of rain that has come down. And those data are also available in tabular form down here. And again, you can download those data as a comma-separated value file. So that's on the hydrology side. There's water quality estimates from this model as well that estimate sediment, nitrogen, and phosphorus yields and attributes each of those water quality parameters to a different land use compartment like hay pasture or cropland, as well as point sources, septic systems, farm animals, and a few other categories. You can sort these data within the table to see where the sediment, nitrogen, and phosphorus loads are highest in which types of landscapes. So this is, and then there's a table down at the bottom that has the total loads, loading rates, mean annual concentrations, and mean low flow concentrations. Similarly to the site storm model, we can also add changes to this area. When we click on the Add Changes button, we open new scenarios. We can manage the names of these scenarios and whether we share them or not with the drop-down here. And we have access to some conservation practices that we can implement on this landscape. Here we have a different set of features, and we're still developing the tools here. So these conservation practices should expand over the coming 6 months to a year. But these are separated into rural conservation practices and urban conservation practices. And there's, if you hover over each one, you can get a little explanation of what these conservation practices are. So probably most of us know what cover crops are. When we click on cover crops, the tool tells us there's a certain amount of area that's available in row crop agriculture for us to implement cover crops on, and that we can choose to put cover crops on a certain number of those. So here I'm going to say 1,000 hectares out of the 16, almost 17,000 hectares that are available. So this would be 6% of the area row crops. We implement that. Once we do, the model is rerunning and developing new predictions, and we can continue to implement more BMPs on this landscape. On those 1,000 hectares of row crop, we'll also add conservation tillage, and we will implement some nutrient management strategies on those row crop areas with our project as well, and we can apply those to this landscape. Over here on the right, we are tracking the BMPs that we're deploying, and when you click on them, it reminds you how much you've put there. So this is a little bit different. We're not drawing areas on the map. We are simply adding conservation practices to a certain percentage of the landscape that these conservation practices are intended to be deployed on. And again, we have updates to water quality and hydrology. With the watershed multi-year model, we have not yet implemented a compare function to see your scenarios side by side. So what you would need to do at this point to compare the model outputs between your scenarios is to click between the two and have a look at the numbers, and or copy and paste these sheets out into a spreadsheet and compare them side by side after you've done that. It takes a little bit of time, and I don't have enough time left in the webinar to do that exercise for you. So that is just about it for the second tutorial. There's a few other things I'd like to share with you before we go, and I will head back to a new project and share with you that there are some tools and functions within Model My Watershed that are only available in the Delaware River watershed. And this was made possible through funding from the William Penn Foundation. They're located in Philadelphia and have a fairly large initiative within the Delaware River watershed to protect and restore water quality. So there are some layers here that may not be available in your region. We have a Delaware River Basin high-resolution stream network that we've developed with colleagues at Utah State, David Tarboten, and what this layer shows is even the very smallest of potential little streams. When we compare this layer to the USGS medium resolution, you can see the difference in granularity of the network. In addition, there are some other data layers that have been loaded here that are called SRAT, Stream Reach Assessment Tool. This is a special product from a model run of map sheds to distribute the nitrogen, phosphorus, and sediment loads into every stream reach within the Delaware River Basin. And these are color-coded. This one I turned on was total nitrogen, so that red shows us where the model would predict total nitrogen to be highest is red and lower in green. And as we zoom in and out, we can begin to see some areas where we have higher nitrogen loading, and therefore if we're involved in projects to protect and restore water quality, we may target our work in these watersheds. Lastly, under the Observations tab, there are some point observations, and these are all limited to the Delaware River watershed area. But the one I just toggled on was the USGS National Water Information System. These would be all the stream gauging sites. So we click here, we can see the historical USGS data, and we can even get time series data from this station if it's reporting, and we can go back in time to look at things like discharge or perhaps water quality if that station is collecting water quality data. We do hope at some point in time, pending funding, to make some of these features available nationwide. Let's see, a couple loose ends here before we open up for questions, but perhaps Deb could open up the chat window and start asking for questions. And while she does, oh, go ahead, Deb.
Unfortunately, it just dawned on me from when we did our quick test this morning that once I open that chat room, we're going to lose your screen.
Okay, so 1 second then. Let me just close by letting you all know that the Wiki Watershed website is currently free and available for everyone to use. We're able to make that happen because of some grants from William Penn and the National Science Foundation, and we hope to maintain it as a free tool. But there are data costs that we're paying, and we are open and welcome to any donations, so we have put a donation page here. As little as $5 goes a long way to helping us continue to serve data up to the general public. I think I would end with the point that this webinar, in addition to wherever Deb and NACD is going to make it available in recording, we'll post this recording to our videos as well. So you can access this on this page. All right, Deb, we can send it back over to you.
All right. So just before I open this chat room, I think if we need to be able to go back and, in answering a question, if you want to be able to go back to the screen, let me know and I'll move you back to that pod. It'll be a bit inconvenient, but I think we can make it work that way. So if we do have to move back to your screen, let me know. I'll open the pod, and then you'll have to do screen share again, okay?
Okay, great.
All right. So with that, I'm swinging over to the Q&A section here. And I invite our folks to type in their questions and comments. And while we're waiting to see if we have any, because that was incredible, Dave. I mean, it's just very thorough and amazing what you're able to do with this whole toolkit that you've got. I'm not much of a techie myself, but I look forward to playing with this.
Good, so that's good to hear.
While they're typing it in, I do have one question for you that you might be able to answer without going back to your screen. Is what's the smallest scale you can go down to on this? Can you get down to an individual neighborhood, or could you even get down to a homeowner plot?
So you probably could get to a homeowner's plot. The real answer there is kind of depends on the granularity of these data layers. So the land use data layer is 30 meter by 30 meter, is 1 pixel. And I believe the soils layer was also 30 by 30. So that is sort of the limit of the scale of the model. And you really should have a number of pixels in your area of interest to have more or less a valid site storm model. So that's as small as you can go. We have limited the maximum extent, I believe, to 8,000 square kilometers for running either of the models, simply because of the computing power and data service that we would need to cover if people are trying to model the entire Mississippi drainage or some other very large rivers. And we also expect that's not entirely useful for planning purposes. You usually plan projects at a smaller scale than that.
Okay, got you. We have a couple of questions that I'll read here in a minute. Before I do, I am going to switch it right now to your contact information so we can have that up on the screen. And I'll encourage people to keep typing in their questions and comments as we go along here. But Just in case some people do have to leave before we wrap up, I wanted to make sure that we had this up here too. So from Brooke at the Franklin District in Ohio, we have what kinds of local data could be uploaded, imported?
For Model My Watershed, the only thing that the user can currently upload is a polygon for your area of interest. And I didn't demonstrate that tool so that I could if we flipped back over to my screen, but it's not necessary. But if you know geographic information systems, you might be familiar with shapefile or a GeoJSON file, and you can upload that polygon of your area and use that to polygon then to run the model. I think the broader context of what kind of data can be uploaded is a question for exploring our Monitor My Watershed tool, which might be the subject of a whole nother webinar in the future. So I'd encourage you to explore that tool.
Okay, great. And then from Chuck in Wisconsin, we have, what is the temporal distribution in soil antecedent moisture condition associated with a 24-hour storm?
Yeah, great question. I'd have to go and look at the code and see what that is set at. I could probably answer that question offline, but I have a feeling we've set it to be a fairly dry state.
Do you want to go back to that pod and?
It would take me some time to dig through that, so I can try it. If Chuck's needing that answer, he can email me and I'll try to get to him.
Okay. Okay, let's give it a minute here. If anybody else has any questions, I saw that a few had started typing something, and maybe we've already answered them with these 2 or 3 here. You have one that's possibly coming in.
There's usually a question about English units versus metric units, and I can let you know that we are working on a toggle that we'd like to add to your profile to choose whether you'd like, inches, pounds, rather than centimeters, kilograms, and hectares. But that's probably a couple months, maybe 6 months out still.
All right. I hadn't even thought about that, but that's a great point. From Cindy, we have any idea when you might have Alaska and Hawaii?
Well, it's certainly something we're not currently working on. It's not in the workflow, and we don't have funding to expand to those areas. So it would be funding dependent, and we're always looking to explore those opportunities with potential funders.
Okay. And that would be something I might suggest to our folks who are listening. If you do know of potential funding sources for projects like this, I would definitely suggest that you pop an email to Dave and give him the contact information.
Yeah, that would be helpful.
All right. From Debbie, we just finished a watershed management plan. Pretty excited to be able to show producers how conservation practices can improve water quality. That's a great point, and especially where you were showing, Dave, the educational side of this, but how they can use that for it.
Yeah, I think there's a lot of value here for communicating to the public how these predictions are made and how we predict what we do on the landscape alters water and water quality. I think, yeah, it'd be really fun to hear people's feedback if they do use this in that way. I would let you know that under the help, let's see, is it under the help menu? We have a way for you to report any bugs or request new features. Of course, new features require funding, or contact us with any other thoughts or questions. So,
all right. Did you want to be able to show that? Should I go back to that?
Yeah, sure. I can show folks where that is.
And then you'll just need to share screen again.
So on the Wiki Watershed page, if you go to Help and See All, You'll see that we have tutorials. I was under the reference document for the technical information. We do have curricula that we've worked up with our National Science Foundation funding for middle and high school. This is made available through the Concord Consortium's website called ITSE Portal. And there's contact. If you have questions here, you can submit report bugs or feature requests or other things here.
And while you're still on this page, there was one place, I think it was Model My Watershed, where you had users, the users list.
How do you mean? Let's see.
I don't remember. It was when you and I were, maybe it was my account. When you and I did the test run, and I had asked you about most of the users listed at this time were university related.
Oh, yes. Yeah. So under my account, your profile, user types. Is that what you're?
Right. And you said at some point you look to be expanding that, correct?
Yeah, we're under discussion right now about these categories and broader applicability. This comes from a database that is maintained by the Consortium of Universities for the Advancement of Hydrologic Sciences, and we're borrowing their categories, but we'd like to somewhat change these and expand them. So if you have a category that is more applicable to your work, I'd be fine hearing about that from you all.
Cool, and that's where I'll put a plug in for conservation districts. I'm going to go back to the Q&A.
Yep.
Okay. A few more that had come in. All right, from Matthew, excuse me, in Ohio, we have, this is truly wonderful. I cannot wait to share with our office at the Stark-Sloan Water Conservation District. From agriculture to urban to education, this is so very helpful. Many thanks will all help to put this into fruition. And I agree with you wholeheartedly on that one, Matthew.
You're welcome, and thank you all for that. As I mentioned at the opening slide, there's a number of people involved in the project. So, yeah, thanks to the team that's made this all possible.
All right, and if, Dave, are you okay to go for another couple minutes here?
Absolutely, sure.
Okay, so before I read Brooke's additional question here, for those folks who may have been typing something in when I switched pods, we did lose that, so I invite you to go ahead and try again. From Brooke, we have, can you change land use numbers directly and or use the change tab and or make multiple changes for a single scenario using the change land use tab?
Yeah, so there is a little bit of difference between these two models in how you can modify the landscape. In the site storm model example that I gave you first, you draw a polygon on the map, and you can choose any land use. And when you draw that polygon on the map, it looks at the land use underneath it and cancels it out and replaces it with your new land use. So that's how that particular function works. You cannot draw polygons on top of polygons, so that's a limitation for the land use changes. But you can open a new scenario and change the land use in a different way under a new scenario. The watershed multi-year model does not have the functions embedded in it yet to change land use. We have only made available so far the implementation of those conservation practices. But that is an area that will be updated within the next 6 to 8 months as we integrate more and more of the full functionality of that particular model into Model My Watershed.
Okay. So we have a couple more typing in. I'd offer to go back to that pod, but we'll lose those, unfortunately. See if these come through. We'll give it just a few more. There we go. So from Chuck in Wisconsin, does the infiltration algorithm consider subsoil conditions below the surface layer? In other words, clay layer 5 feet below the surface, restricting infiltration?
No, it does not. I will need to go back and look at the notes on how the GSurgo data set was compiled, because there is some vertical distribution data in that larger data set. And to give you the exact answer, I'll have to go back and query how that vertical structure was processed into, a single value for the hydrologic soil type, the infiltration, the high versus low infiltration categories.
When you say go back, do you want to go back to the pod now, or is that research?
No, I'll have to do that online. If Mitch is wanting that, please email me.
And what I can do is send you these questions even and the email addresses if you'd like, Dave.
Yep. Oh, that wasn't Mitch, that was Chuck.
So we'll take this last question and then we'll go ahead and wrap up. From Mitch, we have, you mentioned an area threshold for when to transition from the site storm model to the watershed multi-year model. Do you have a recommendation on that area threshold?
I think what I usually say is, well, number one, it does depend right now on what sort of changes you want to modify. Certainly you can apply the site storm model to a large landscape and use it. It does have, it's not as well trained a model as the watershed multi-year model for large scale watersheds. So the reality of the estimates may be sort of further away from reality than the watershed multi-year. I usually try to focus down to something in the neighborhood of 20 city blocks or smaller with the site storm model. I've used it on larger landscapes. The other couple points for the watershed multi-year model that I did not bring up were there were a few other base GIS layers that are feeding that model that help us better estimate nitrogen, phosphorus, and sediment. So there's a USGS national map of soil nitrogen concentrations, soil phosphorus concentrations, and groundwater nitrogen concentrations that are ingested into the model to predict nitrogen, phosphorus, and sediment loads. So I think on a larger scale, the watershed multi-year model is a little bit closer to what you might actually measure over a year as far as loads coming out of a stream.
Okay. Great. So I'll take this last comment, and if Christy doesn't come in, we'll move on. From Eric, we've got great job, Dave. Thanks for sharing this. And from Christy, we've got, she'll share it with the NRCS folks. Thank you.
All right.
And I agree with Eric and everybody that's commented on. Great job. This has just been a really interesting webinar, very useful.
Well, thank you for giving me the time to share it with you all.
Excellent. So what I'll do for all of our folks is this has been recorded, as I mentioned earlier, so we will go ahead and get that edited, and I'll send the web link to everyone for that. And we'll also get it posted on NACD's website. And in the meantime, I encourage folks to check out the resources we do have available at our website, as well as, probably more importantly, encourage you to participate in our Facebook page, where you can share information and ask questions of each other there. And then finally, I invite you all to join us for the January 18th webinar, which will be on outreach to communities, and will feature what a couple of districts are doing. I'll open that registration after the holidays, so right after the first of the year, and we'll send an advance notice to everyone. So thank you again, Dave, very much for your presentation. I thank all of our participants, and I wish all of you a wonderful holiday season. Bye now.
Happy holidays, everyone.